Hello friends, welcome to the second part of vector learning, and now we will talk about more vector functions. So in the first lecture you have already had a good understanding of what is a vector, a stale container, what exactly it has. It has different elements similar to your array, but it is dynamic array. So basically it can expand and shrink on its own without you worrying about the size and everything. So today we'll study about resize function, shrink to fit, reserve, and max size. So we'll start with resize without wasting any further time. So resize function, as the name is specified, it resizes your vector. So you need to provide one parameter over here, which I mentioned as n. So if your current vector size is less than n, it will increase the size to n elements will have some default values. But if your vector size is currently greater than n, it will reduce it to n elements and will delete the rest of the elements beyond n. So this will impact your actual vector contents. This is the most important part that the interviewer may test you on. And the other function is shrink to fit. Shrink to fit is a C++ function call. The most important part is it will reduce the capacity of vector to fit its own size. So if the capacity is 20 but the vector size is 12, so shrink to fit will reduce the vector size to a vector capacity to 12, equal to its size. The most important thing is, if you are having some elements in your vector presently, this call will not impact any of your data. Okay, so this is a non-binding function call. The other function we are discussing today is reserve. In this reserve call, if your vector capacity is to increase your vector capacity first of all. So if your vector is having already a capacity of n, this function will not do anything. But if your vector capacity is less than n, this will increase your vector capacity to n. I'll show some examples later on, so don't worry about it. Just try to swallow all the theory. I'm just max size. So the max size function is the maximum number of element which your vector can contain. The thing is, this is just a theoretical number, as it is based on memory limitations, library limitations, your host system configurations and all. So if you call this API now, and maybe after execution of 10 instructions or 5 minutes, you will get a different number. So this is how your vector is gonna acquire all the memory and insert all the elements into it. So this may be a question, if this is a real number or not. So this is just a theoretical number written by max size. Now we'll talk about some exercise. So in this exercise I have tried to explain all the variations of resize, reserve, whatever we are having. So just have a look here. In this, first we are having a vector and we are pushing values into it from 0 to 7. So our vector size would be 8 this time. I'm printing here vector.size and vector.capacity. Just make a note, your vector capacity could be anything. It is depending on your implementation, C++ implementation compiler type. Now vector.resize, now I'm resizing my vector to size 5. So earlier the vector size was 8, now I'm resizing it to 5. What would happen? It will delete the rest of the element. So your vector size after this call would be 5, but the capacity is still 8. So you need to remember, resize, as the name is specified, will only impact the size part of vector, not the capacity. Now I'm trying to increase the size. It is resize 8 with the default value of 100. What it will do? So the size of vector was 5. Now I am asking it to make its size 8. So it will increase the size by 3 elements. What would be the initial value of these 3 elements? 100. So if you see a vector.size, it would be 8, vector.capacity, it would be 8. And then you need to remember, if you increase the size as I'm doing here without specifying any initial value, the initial value will be 0. So after this resize call of 12, you can see the vector size and vector capacity both are increased, and capacity is a number you can see differently on your screen, so don't worry about it. Then we are talking about a new function, shrink to fit. And shrink to fit This, what it will do, as we have already discussed, it will shrink the vector capacity and try to make it equal to the size of the vector. Just remember, this is a non-binding call. It is depending on the implementation too. So if you don't see anything, don't worry about it. So now here we can see we have reduced the capacity to 12, which was earlier 16. So this function worked in our case. Now in last thing, we are just printing the vector element to assure like what changes we are doing are actually taking place. Here we can see the first 5 elements which we have not changed anyhow throughout the program. So this will be 0 1 2 3 4, and then the default value of 100 for 3 elements, and the default value of 0 for last 4 elements. So this is your vector part 2 example. You can compile this program using C++ 11 standard using this command, and you can run in this. Okay, I hope you had a good learning here. If you have any question, any comment, just feel free to post a comment and I'll try to reply it as soon as I can. Thank you so much. Bye bye.